Hi everybody, and it's Invictus Elite Tuition, and today we're going to be talking about 3D similar shapes and working out problems related to them. I'm going to show you the method for doing it and the background to that method, and then there are a couple of practice questions for you to have a go at the end. I promise by the end of this you'll have a method to deal with these problems. Now, what is a similar 3D shape? Well, here is a square-based pyramid, and here is a bigger one. And they are similar. Now, what do I do? How do I get that smaller one to that bigger one? Well, because they're similar, I go through a process of enlargement by using a scale factor. I'm just going to give you the length of this edge. That's 10 centimeters and that's 20 centimeters. So instinctively, hopefully you can see that the scale factor here is just 2 because I multiplied 10 by 2 to get 20. Okay, let's have a look at some background stuff though that is important. But before we get there, this is the sort of a question we can encounter. And I don't know about you, but I've only read the first 2 lines and my brain has done this. And the only way I'm going to get through it is by knowing this fundamental stuff. So in maths, we measure things by length, area, and volume. And what I'm going to do for my example here to explain the background to the method is that I'm giving my line a length of 1 centimetre. I've got the side of my square is 1 centimetre and the edge of my cube is 1 centimetre as well. Okay, all seems fairly simple so far. Now I've got a new line and that's 10 centimetres. So let's think about this scale factor enlargement thing going on. And what does that mean? Well, my scale factor, what have I done to get from 1 centimetre to 10 centimetres? Well, I've multiplied by 10. That is my scale factor. Now let's just think about what the area of my square is. Well, it's 1 by 1. That's 1 centimetre square. So does that mean that the area of a 10 centimetre square would be the same? Well, it's not. So the scale factor here, because the area of my new square is actually 10 by 10 or 10 squared. And you'll notice that this is very similar to the scale factor of the length, but squared. And that's a really important thing to hold on to. How about the cube then? Well, the volume of my 1 centimetre cubed is 1 times 1 times 1. 1 centimetres cubed. Is that going to be 1 centimetre cubed? 10 centimetres cubed. Well, no, it's not, because an edge is 10, then 10 times 10. That's the scale factor then of 10 times 10 times 10, or 10 cubed. Now, this can be a little bit confusing, but the important thing I want you to know is that length is the scale factor, area is the scale factor squared, and volume is the scale factor cubed. Everything hinges at this moment on that scale factor being generated from the length. Okay, let's get rid of all of this and let's make this a little simpler. Here's a table. You don't have to reproduce this exactly, but it is a great way of laying out your information. Here are 2 cylinders, object A and object B, and I've got 2 length measurements. Now here, it's the height, but it could be the diameter, it could be the radius, it could be anything you like, as long as it's 2 similar measurements of length. All I'm going to do now is going to put that information into my table. There's the length that I'm interested in for object A, and there's the length for object B. How do I get from 6 to 12? Well, I'm going to multiply by 2. That's the scale factor. Remember I said in the previous slide that everything is linked together. Without any hesitation now, I'm going to square that scale factor and cube that scale factor. And now I'm ready to answer any questions. So my first question is going to be the area of the circular end of A is 24 centimetres squared. What's the area of the circular end of B? Well, how am I going to work that out? Well, it's easy. What am I going to be looking at here? It is area. So I put that area number in for object A, it's 24. And all I have to do now, just as I did for the length, is multiply it by the scale factor squared. So the area of the circular end of B is 96 centimetres squared. Here's question 2 then, or second part of the question. The volume of A is 144 centimetres cubed. What is the volume of B? Okay, this is the volume part of A. So I put the 144 into object A, multiply it by 8, because I have to multiply it by the scale factor cubed, and that's the answer I get there. And that's it. From just knowing about 6 and 12 and generating the scale factor, and then the scale factor squared and cubed, I can work out anything else I want to. Okay, it's your turn. Now, these two pyramids, they're similar, just the same as the ones from the initial slides you had. And I'm going to tell you that that edge and that edge, the two lengths here, are similar. Okay, these are the questions I want you to ask. Pause the video, and when you've had a go at it, come back and we'll work through the answers. Okay, welcome back. So the first thing I'm going to do is I'm going to put these numbers into my table and work out scale factor. And how do I get from 10 to 30? Well, I multiply it by 3. And then without any hesitation, I square it and I cube it and I get those numbers. Now I go to part 1 of my question, and this is the area of the triangular side of the small pyramid. I'm not too fussed about what it is. What I am fussed about is what it represents, and it represents area. That's an area on A. So I'm going to put that into that part of my table. And now I can instantly work out what a similar triangle on B is just by timesing it by 9. The second part for the volume, I'm going to put that into the table of 52. And again, multiply it by 27, and I get 1,404 centimetres cubed. And that is it. If you got those answers, fantastic. If you didn't, just go back and see how I went through the process. I hope you've really enjoyed this video. What I'm going to do is I'm going to put up a couple of links here to a couple of other videos that might be of use to you in any of your studies that you've got. And hey, help me out here. Subscribe. It really is painless. You just got to hit the subscribe button and the notifications, and that means you'll be able to search through all of the videos I've already put up, and I do very regularly post. And if you've got any questions, any video requests, just send them to me. I hope you enjoy.